Hello and welcome. I'm Joanna Junak, and in today's program, Roberto Sussman will tell us about the secrets of effective vaping: settings, airflow, and temperature control. Roberto, could you please explain to us how airflow impacts the efficiency of vaping?
Well, airflow is the forced convection. You generate vapor inside of it here, and at the same, almost instantaneously, you are evacuating this vapor. What does it mean, evacuating? You are forcing it out. And this is the thermal process. The absorbed energy is called thermal convection, or it can also be called forced convection, right? And this is the airflow. So the airflow has to be proportional to power. If you're supplying a lot of power, you're generating a lot of vapor, you need a lot of airflow to evacuate it without producing too much residual heat. The problem is the residual heat. Whenever this equilibrium does not hold, you pay with residual heat. Residual heat is problematic. If it is in small amounts, it's okay, right? So airflow essentially has to be proportional to power. If you supply a lot of power, then you also need a lot of airflow to evacuate and condense this power, this vapor, and form the aerosol. You need to move it, and this is the airflow. It is important. It is a key ingredient of the cycle. Remember, the cycle is supply energy. That energy is supplied to vaporization, and is also supplied by the convection, right? And then some residual remains, and it settles down and it goes slowly to equilibrium until the next puff, right? And the cycle goes on. But airflow is an important part of this cycle because it's the energy that is absorbed to pull out, to evacuate and condense the aerosol. You need energy, you need to absorb energy to that. And that is part of the energy that was supplied.
So, how do users adjust their vaping device settings to achieve the desired effect?
Well, the user can adjust power, and they can also, can also adjust the airflow. The airflow is not going to be only what you inhale, but these slits, they either close it to make what happens is it's also this another parameter. It's called air resistance. Like if you look at the high power devices, the mouthpiece is very wide, and in the small power devices, the mouthpiece is very narrow. So imagine a straw, one of these straws that you use. If the straw is fat, then it's much harder to. But no. In fact, if the straw is wide, it's very easy to. You just have to, and that's it. All the air enters. And if it is narrow, you have to push. The suction. You have to involve a lot of suction. This is the air resistance. And the air resistance is also something that you adjust depending on your comfort. Like typically, if you are going to puff a very powerful device, devices have very wide mouthpiece, and this mouthpiece, they facilitate a very natural inhalation to the tidal volume. It is very easy to right? You need a very intense inhalation that has to be that has to originate deep in your lungs, and this is facilitated by the design of the devices. Now, if you have a low power devices, they have narrow mouthpieces, right? So and you can adjust it because it is always a trial and error process. There, no, sometimes you find a device and you don't have to modify anything, right? But normally you try. It's the same like if you have any product like a car, you make some modifications of the car. You put different type of tires, or you might I don't know. There's the computer. You install different software. You put some skin protector, and it's the same with vapes. A lot of it has to be you customize them, and whenever you customize them, you alter a physical parameter. Like if I open the sleeves, then I'm going to decrease air resistance and increase airflow, right? And this has to be proportional to the power, because if I excel a too intense airflow with little power, I'm not going to get much aerosol, right? So I have to put more power or decrease the airflow. And a user doesn't know physics. A user, it's instinctive. But the fact that the market of these devices is increasing in spite of all the disinformation and so on, means that users easily are able to customize them. That's not a problem. That's not a problem. And also, you have a community or network of vape owners and shop owners and so on. And you can, and this is one of the reasons why vaping has been successful, because there is always a community that will advise you. There are forums, there are magazines, but essentially users can customize it on their own. And each time they customize it, they alter a physical parameter. And, and if they customize it well, the thermal cycle will be efficient with little residual energy, and vaping will be enjoyable. It stops being enjoyable when you alter the chemistry because of overheating, right? And that has to do with the temperature dependence of the reactions. If you are in the optimal regime, the reactions are weak and the taste is okay. The moment you go above, then it's the same thing. Look, a car. I drive my car. One day I go crazy and I do 200 kilometers an hour. Well, it's but most of the people will not do that. Only some crazies. But when a product is demonized, like vaping, then everything that goes wrong is painted as if it was representative, when it is not. And every single consumer product can be deadly. You can kill with a car. You can kill with kitchen knives. But nobody is in panic because some crazy person used a car to kill somebody. There's no panic about that, right? But with vaping, there is panic because we have a technocracy that is annoyed by this disruptive technology.
And why can temperature control be inaccurate in some devices?
Because, see, what happens is that these devices use resistances. The resistance of the coil depends on the temperature. Therefore, the resistance becomes a proxy for temperature. But the liquid has a temperature also, boiling temperature. So you use these devices, you have to do a lot of trial and error, because also the temperature, the resistance does not, as I was telling you, the resistance is acting as proxy for temperature because it depends on the temperature. But the dependence all this has to be modulated by an electronic controller. The electronic controller will have to decrease the power to compensate with the resistance. And some of these devices are not very accurate. We have tested them in the laboratory, and if you use them with the right airflow, they are more or less accurate. And what happens is that the real temperature, let's say there are many temperatures in vaping: the liquid, the aerosol, the mouthpiece, the walls. Let's talk about the important temperature, the coil temperature, right? So the coil temperature has to be very close to the boiling temperature, right? So if you choose a temperature in your through this resistance that is very different, it will be very difficult for the electronic controller to juggle all these parameters to get the boiling temperature. Or these devices require, they're not for everybody. If you buy a device with temperature control, you better have a know-how on how to adjust these parameters. And you even need some technical know-how. But in a lot of cases, the parameter, and there has been laboratory tests. We have done laboratory tests also. We've seen that they are not, if you have to measure the coil temperature independently and compare it with the temperature that appears in the instrument dial. And they can be very different. They are not very accurate. Temperature is not the important key parameter. The important key parameter is power. Power, resistance, and airflow. These are the important parts. Temperature is a product. Like if you supply a certain amount of power, you will get a temperature. See, power is very easy to control, right? Here, I control it here. I put the power, right? Or with a switch, you control power, right? The amount of watts, it can be controlled. Temperature is very complicated because first, temperature, you have many temperatures, and temperature changes, even in a small space like this. You have big changes in temperature. Remember the cigarette, 950 degrees, 10 centimeters below, 40 degrees. So what's the use of talking of temperature when temperature might refer to the coil, right? It's easier to measure, but you have other temperatures. On the other hand, power is important because it's a supply element.
Stay tuned for the next part of our science series coming in a couple of weeks.